de la ciencia y escritora. Su último libro se titula Watchers of the World, The Story of the Scientists Who Unraveled the Mysteries of Our Oceans, Atmosphere and Ice Sheets and Made the Planet Whole. Apareció por la Universidad de Chicago, la editorial de la Universidad de Chicago, en el 2019. También es autora de The Woman of the World, Dana Meadows, The Limits of Growth and the Invention of Systems Thinking. Este aparecerá en el 2027 por la editorial de Princeton. Bienvenida, Sara. And Liz Richard, que algunos de ustedes conocerán, es, como dicen, suelen decir en Cambridge, una gloria local. Es doctora en antropología sociocultural por la Universidad de California, Berkeley. Es profesora investigadora adscrita del Departamento de Humanidades de la Universidad Autónoma Metropolitana, Guatemala. Ha publicado artículos, capítulos de libro sobre organizaciones civiles y globalización, historia de los movimientos ambientales, tecnociencia y cultura de expertos, antropología de la alimentación y nuevas ruralidades. Es autora del libro The Unsettled Sector, NGOs and the Cultivation of Democratic Citizenship in Rural Mexico, que apareció en el 2016 por la Universidad de Estado. Bueno, entonces, adelante, por favor, y pues gracias a ambas por participar.
Gracias, Carlos. Y qué suerte estar contigo. Ojalá que pudiera dar mi presentación en español, pero por todos, I'm going to speak in English from now on. And welcome your, obviously your questions in whatever language you're more comfortable with. And also during the presentation, if you have any questions, not only about language, but also about the content, please feel free to interrupt me. That's more of a convention, I think, with scientists than it is with historians, but I think it's one of their conventions that I quite like. So it's a great honor to be here, and I'm just going to dive in. What I'm talking about today is really the first time that I've spoken in public about this almost finished book project, which is now in peer review. And I say this because we're very much about to start revising it. So this really is a live talk in that sense, and a great opportunity for me to try to formulate, a 60,000 word book into a talk. And it's important to note that I co-wrote this book with Professor Mike Hume, and it was a delightful experience of collaboration. I know they're not always that way. This was my first real sustained collaboration, and when it works, it's just you kind of get twice the material for half the work, and yeah, so it's been a happy. So let's see. So this is my plan for the talk. This is roughly the outline of our book, although it has more chapters than that. But I'm going to start out briefly by talking about the kind of early period. Our book sort of starts in 1873 for a kind of fairly good reason. Then I'm going to talk a little bit about the unstable state of both climate and climate science in the 70s. Then I'm going to spend some time talking about two key institutions who each created a large-scale index of temperature in the late 70s, early 80s. And they are really the core of our book. And to produce this material, the material on what I'll call CREW, which is an acronym that stands for Climatic Research Unit. I'll get to that. Part of the project involved doing some oral history interviews, which was also a delightful thing to do. And I also really recommend that if you can manage to get funding. And one outcome of the project has been the creation of an archive of those interviews. And at the end of the talk, I have a QR code. It's up. I'm very happy to say it's up in the Cambridge University Library. Very accessible now, actually. And we spent a lot of time creating transcripts. And these interviews lasted from 2 to 8 hours. So it's a lot of material, which I hope other historians and researchers will use. We could only use a small bit of it for the book because it's a brief history. Then I'm going to talk about the differences between those efforts of these two institutions, which I think are quite instructive. Then I'm going to talk a little bit about, I'll probably not spend much time on it, but about how climate policy evolved throughout the 1980s. We chose to end our book in 1990, and I'll tell you why. And then at the end, I'm going to talk about lessons for today. And then in a sense, I think that might be the place where there are the most opportunities for points of contact and ideas from you. So yes, without further ado. So our book traces, in a sense, it's a very simple story. We're inviting people to consider that something called global temperature, which I think for the most part people understand, and when I say people, maybe not people in this room, to be a natural thing about the world. That it has a history, and like all histories, there's contingency in that history. That is to say, it didn't have to emerge the way that it did. And the history that we tell is notably quite different than the history that scientists who have created these indices tell, which has a lot more teleology in it, a lot more of a sense of inevitable progress towards a point. You may note when I am speaking, however, that the teleology creeps in. It's very hard, and we were sort of aware of it, but not able to completely expunge that. When you're writing a book about global temperature, it's hard not to sort of see all roads leading to it. But we've taken a lot of effort to show that there was nothing at the time for those researchers involved that made it at all seem inevitable or natural that such a thing would emerge. And I think therein lies some interesting lessons for today. So just a rough précis of the book is that we demonstrate how large-scale indices of temperature were developed throughout the late 19th and 20th centuries for a range of purposes. That's important. By largely independent researchers working independently from each other, seeking to understand the causes of natural climatic change. So to distinguish between potential causes of climatic change. And then we focus on a shift that occurred in the 1970s, which eventually led to the creation of these two distinct indices that I've already indicated came out of these two units, which both made what were at the time credible claims to being fully global. But there's always, you can put quotes around global for a long time. And then we explore how these two groups, along with a cohort of international researchers working in other institutions around the world, became what they still are today, which is authoritative metrics of anthropogenic climate change. So a metric, rather than the word I'm going to use is heuristic in Spanish. Okay. So that's a kind of important shift that we track from heuristic to metric. And then we end with the adoption of this metric by the Intergovernmental Panel on Climate Change in its first report in 1990, which we take to be the kind of crowning of the king or the emperor, as it were. And that's our that's our off button. And it has subsequently been included in all its later reports. Okay, so just quickly on, oh, hang on, my timing isn't good. There we go. So our first kind of substantive chapter is the history of these early efforts, and they're all slightly different. I'm not going to go into the details of exactly how they're different. I actually find it very hard to remember all those details. The point is that, as I said, what the motivation for creating these, so again, I keep saying large scale because they weren't global. For the most part, they start out, as you would expect, with records that are largely European and American. And I guess I should say now that our book is not a history of measuring temperature. So we sort of start in the introduction and we say, hang on, yes, there are thermometers. Yes, there's a lot that can be said about thermometers. There's a lot of histories one could tell about thermometers, which some people find interesting. They're called station histories. So every thermometer in a given place has a history that's actually scientifically relevant. And one can tell the history of how those records have been gathered. So we're coming into it sort of at the other level where we're more or less assuming the availability of large enough collections of data, which our researchers use. And we're more interested in what their uses for that are. And so really what they're generally doing is trying to sort out the relative contributions of things like sunspots, volcanoes, changes in circulation to the natural variability of the climate, right? And there's a really, I think, important part about this is that for them to sort out causes, what was often the most useful thing was to contrast
different zones of the planet. So the global was actually sort of no use to them. If you're trying to find out the relative contributions of things like sunspots or volcanoes or solar radiation, looking at sort of southern hemisphere versus northern hemisphere versus southern is more useful, right? Because you can start to see differences in patterns that might give you a hint at the kind of underlying dynamics. So this is an indicative image. The map we actually created that shows you where Vladimir Kopin's data came from. It's hard to see, but you see there's like dark cluster in Europe, and there's a few X's in North America, and maybe a few in Asia. So then he took these data and divided them up according to latitude zones. That's what the chart on the left is showing you. And he's trying to determine underlying patterns, which is, what meteorologists and, well, climatologists, that's what they did, right? I mean, it was a very complex thing to try and sort out. And, the notion of anthropogenic change for Köppen was not relevant, right? So I'm just going to show you a few other images from these other people to just make my point. I'm not going to talk through them, but I like this one because you can see the volcanoes on the bottom. So those are volcanic eruptions. And then he's trying to find correlations between sunspots and then pyroheliometric values, I think is like solar radiation. And then the second from the bottom is P plus S. If you add them together, the lowest line there is the temperature record that he creates. So he's saying, look, there's a pretty good fit between temperature, sunspot, and then maybe you could make an argument about volcanic eruptions and cooling. The point is that nobody really, it's testing theories, right? Here's another example of this. And again, sorry, these graphs are all kind of, in a way, incomprehensible. But the point is, there's southern hemisphere on the left and northern hemisphere on the right. So you're comparing southern and northern. And then all of those stacked up things are the different latitude zones of temperature. So it goes from the equator to the poles. Like you have to flip them around. So the fat thing at the top is the Arctic and the Antarctic. And what this is showing is that there's warming in the Arctic while there's cooling in the Antarctic. Can you see that? The yellow. The point is, it's not you wouldn't see that with a global measure, right? You only see this difference in warming and cooling by disaggregating. So he's creating these, and they're also like latitude zones. They're not really fully hemispheric, right? He's like finding as much data for like a given band. There's never very much for the poles, which is always frustrating because the warming and cooling is greater there, and so you want to see it more. Anyway, this is just my my sort of bowing down to data. So the data that they used after 1927 mostly comes from these world weather records that are published by the Smithsonian Institute. So this is just a way of saying, yes, I know data is a part of the story. We get it. We just haven't really focused on that so much. Okay, so now I wanted to talk about this kind of interesting relationship between the state of climate science and the kind of understanding of climate in the 1970s. So as I've said, the global scale was only sort of fitfully employed, so only sometimes used, and often was seen as less useful than the hemispheric scales that could be contrasted. I think that last graph is useful for showing that. I guess I should say something here, like why temperature, right? That's a question. And you may not be surprised to hear that it has to do with a kind of Anglo-European bias, that temperature was understood to be a kind of useful indicator of basically agriculture in Europe, rather than precipitation, whereas in places like East Africa or India, where you have much more seasonally different rainfall, precipitation might give you a better indicator of the stuff that you really care about. So this was a very kind of typical form of like Western, egocentrism, that they chose the indicator that was the most relevant to their part of the planet. And again, it indicates they weren't necessarily thinking of globally either. And also it is true that temperature has been recorded, for a long time. There are long, like temperature and barometric pressure, but but one thing to say about the 70s, I guess, is that climate is still being investigated on a range of scales, right? There's this concept of the global in climate is really not at all dominant. And I'm going to try and give you an example of this with our friend Murray Mitchell, who for years, when I was writing this book, we hadn't seen a picture of him. And we always call him the elder statesman because he was the older generation. And so I was shocked to find that he was kind of a boyish, like a NASA geek in the 60s. And he was very interested in compiling historic temperature data. He worked first at the US Weather Bureau, and then at what became the National Oceanographic and Atmospheric Agency, NOAA, one of the many institutions that Trump is in the process of destroying, sadly. And he wrote several important papers for which he produced large-scale temperature trends, again, to try and understand the natural cycles of climate, right? And he's still using a lot of, he's still contrasting southern and northern hemisphere. Now, I'm sorry, you can't read it on that graph, but the 3 lines on the graph correspond to the northern hemisphere from 0 to 80, so almost to the pole, 80 degrees latitude, 90 is the North Pole. And then also from 0 to 60, I think those are the top 2 lines on the bottom. And then the longer dashed line on the bottom is southern hemisphere. Only from the equator to 60 degrees below, because there just wasn't data for below, for further south. And he's looking for a signal of something. It's not global warming. It's just like what makes the climate tick. But no clear signal is emerging. And you can see still this contrasting use of the different hemispheric measures. He finds evidence for warming in some parts of the globe and cooling in others. And there was a warming trend in the northern hemisphere, which starts to reverse after 1940. Is that right? Yeah. But then in the southern hemisphere, it's flatter. And again, I'm sorry, you can't really see this here, but the point is really that it was confusing and it was hard to identify a clear signal. But he still has this idea of a kind of stable long-term climate, which is a kind of inheritance of kind of climatology in the classical manner, right? So he's still looking for sort of the long range stuff. And what he's finding actually are that there's all kinds of differences depending on how you slice the globe. And so I think in the book, we write that kind of his emphasis on these fluctuations in climate is a good proxy for the state of understanding of climate scientists themselves. So just as the climate was sort of hard to pin down. So climate change was receiving more public attention, more to do with aridity than to do with the results of carbon dioxide. So the result of, for example, deforestation in certain areas that could create arid environments. But it was change itself rather than a trend towards warming or cooling that was of concern, because there was this idea that human beings had evolved to live in kind of a stable climate. And if you had fluctuation too much in either direction, it makes life harder. So people creating these indices used different data, different sampling strategies, different methods for aggregating data, even if they're using the same data sources that I showed you. And as I said, they were trying to test hypotheses about that. Let's see. So one fun part of this project was interviewing a New Zealand climate scientist, actually Michael Salinger, who wrote this paper. So at this time, you start to get I mean, I think it's amazing how late it is. It's only in the 1970s, really, that you get significant new data from the Southern Hemisphere, meaning like somebody in New Zealand bothered to go and look up old records and add them into the kind of global mix. And that graph on the right is a chart from another paper put together by Australians. Again, they were more familiar with the records from their part of the world. They were more attuned to the fact that changes in the North weren't necessarily representative of changes in the South. I mean, in a sense, these aren't actually that subtle kind of, their motivations were, not their motivation, their perspective was like very grounded in kind of an ordinary understanding of weather and climate. And what's notable is that you start to get communication at the international level between these groups, right? And so this piece with the map in the middle, they publish a short piece in Nature that gets read by some of the scientists in the North. And then again, this is just, this is my placeholder slide to say the Soviets were also doing their own climate work. They had a long tradition of what we would call historical climatology, so sort of measuring past climates, often involving very tedious and time-consuming mapping of data, like hand mapping, which was always done by women, as is often the case with these things. I got to interview this lovely, I don't know if he's in, the third man from the left in the back there with the glasses, Kostya Vinnikov. I got to interview him. He's just super thick Russian accent. And he said, his English is still terrible. He emigrated to the US in 1989. So he's been there for 37 years, whatever, and still terrible. But he says, Soviet scientists at this time were realizing that climate was not stationary. This is a quote, that everything was changing, and not only the mean value, but amplitudes, seasonal and diurnal cycle are also changing and can sometimes change in shape, and all trends exist everywhere. You had to work with non-stationary world, non-stationary processes. I like that quote because it kind of gives you a feeling that like what they had taken for granted as a stable system wasn't. And this image is just an image from a later meeting that shows that there was quite a lot of contact between Soviet and American scientists on these matters. Okay. The other thing that's happening in climate science at this time is that it's becoming increasingly multidisciplinary. And that means that you have scientists who have developed techniques for gathering data about very old climates, from ice cores and mud cores, paleoclimatology. On the one hand, there's the past. On the other hand, you have the development of climate models used to project future changes. And in the middle sits the historic temperature data that we're interested in. And we sort of use this metaphor of like that this data helped to knit together the past, present, and the future in a kind of disciplinary sense, but of course also in a temporal sense, right? So you're able to create this sort of very long history of the Earth that stretches from the past into the future. And this image is a really good summary of this. It's from a very famous paper. I mean, famous if you know. It actually is a famous paper. It's not the first, but it's almost the first use of the phrase global warming. So Wally Broker, who was a very grumpy old man, he did not like that idea. He was called the father of global warming. He didn't want that. But anyway, so he used in this paper, what we see in this graph is a combination of data from ice cores. So that Camp Century cycles was an ice core that was drilled at Camp Century in Greenland in 1960s. That produced like 100,000 years of history. And then the CO2 effect that is rising is his projected, I'm actually not even sure what the mechanism is that he's using. I mean, that's a very smooth curve there. And then the sort of wiggle is what he thinks are like the natural cycles that underlie climate. But now he's overlaying that with the meteorological records as a kind of check on the ice core records, and as a kind of form of calibration. And then what he does with this is make a very kind of bold claim that we might be on the brink of a pronounced warming. And it turned out actually that he was right for the wrong reasons. That's a whole other story, but that the Camp Century core, this is a whole fascinating thing, that like an ice core taken from one spot in Greenland was again taken as a marker of a global climate. I mean, there are good justifications for that. Maybe the environmental engineers who are listening will chime in later with that. But it turned out that some of the cycles that he had identified in the ice core that others had were only representative of Greenland, and they weren't global. Anyway, that's an aside. So Broker makes this very bold claim that the world was, quote, on the brink of a significant global warming, which, you know, is like the birth of now, right? In a sense. I mean, okay, let me just. So he did try and recognize the fact that the data that he's using was from Mitchell, and it was Northern Hemisphere only. I mean, there's nothing really justifiably global about this data, but I think it's useful. I mean, what's important is that it's so tools like these make the elision of the kind of local or the hemispheric or the regional for the global, I think almost inevitable, right? Or there was maybe a softer way of saying it is that the disciplinary authority of climate science as this multidisciplinary science rested to a certain extent on the ability to make, you know, local is maybe too strong, to make non-global things seem global. And people were very, they made a lot of like, what's the word? I mean, they kept saying, well, I know it's not global. I know it's not global. But once you create a graph like this, and once you create the inference from the graph, all of that other stuff, it gets hidden, you know. We say black box a lot, but yeah. Okay, so now we get to like the two units. And I hope what will become clear is that there's very different cultures in these two places and different methods, and yet they both end up creating something which eventually comes to be taken as kind of as a reified thing about the world, which isn't connected to the institutions or the methods that created it. So we'll get there. We'll get there. So I like this picture because, like, what decade are we in? All right. It's just so 70s. We were pleased when we found this picture. Okay. So just a brief introduction of the Climatic Research Unit, which is kind of famous in the UK, but I imagine not necessarily everywhere. So it was founded in 1972 as part of a new school of environmental sciences that was created at a university in England called the University of East Anglia. It's about 2 hours northeast of London. It's kind of in the middle of nowhere, actually. It's at the end of the train line. But they were quite cutting edge in terms of thinking about environmental studies in the 70s. It was one of the first places to do that. And the remit, the goal of the Institute was to monitor and understand climate. Yeah.
So I can.
Sure, whatever you need.
Thank you.
Is those two?
Oh, the bars are annoying. Yeah. Do you know how to do it? Do you?
Just click on it. Yeah.
Where?
Just click.
Hide video panel? No. Hide floating meeting control. I just turned it off. I think it might. Yeah, because the one I see doesn't have it.
Oh.
I can read it. Shall I read the top ones? But it's not actually on my computer. Okay, so sorry, I just realized it's hard for you to read my slides at the very top. I'll try and, for the people, I'll try and read them. So we titled this chapter Making Temperature from the Ground Up at the Climatic Research Unit. And I won't go into it very much, but it's kind of important to know that there was this generational shift going on at this time. The man kneeling in the photograph is named Hal Fritz, and he was, again, the elder statesman of dendrochronology. So that's the technique of using tree rings to create past records of climate. So he's one elder statesman, and then the other one is a man called Hubert Lamb, who was the founder of the Climatic Research Unit and who was a very, like, what we would say, old school historical climatologist. He was more of a geographer and a historian than a scientist. But he was very sensitive and very attuned to differences in climate in the past, with respect to like human culture and civilization. And this image is from a meeting that took place in Arizona in 1977, where the man in sunglasses in the middle, his name is Mick Kelly, also very 70s. Keep your eye out because he appears later on with the same sunglasses. And some years later, he comes from the Climatic Research Unit to learn about this technique of using tree rings to create records, right? And the other guy who's sort of at the top right, also with kind of sunglasses like higher up, is named Henry Diaz, and he was a NOAA meteorologist who came, and they met at this meeting. And they met one other person named Ray Bradley, who was another climatologist. The names aren't that important, but we care about them because they're kind of our buddies. And they became friends. So they called it the beginning of a beautiful friendship. And I think this is just nice because it shows, it shows how these meetings matter and people have these critical encounters with each other, and it's exciting. And what was exciting was that the younger generation realized that they could borrow from these sort of older tools that were developed by archaeologists studying Native American ruins who used dating of wooden, pillars in ruins in New Mexico and Arizona to date sites, that they could borrow those tools for new purposes that had more contemporary, more statistically oriented applications. So they share this interest in historical temperature data that actually many of them got from Murray Mitchell, the NASA geek looking guy, and understood that this data could be useful for calibrating models of future change, which, global climate models that were becoming more and more kind of important, right? So studying the archaeology of the Southwest of the US is fine, but it's a little more exciting to see if you can contribute to this new science of climate. So after the meeting, they sort of started a collaboration, Henry, Mick, and Ray, to see if they could gather historic temperature data and compile like a larger index. And they borrowed the idea of gradually building up larger areas, ever larger areas, from the dendrochronologists. So this is a quote from Mick Kelly that I will read that sort of gives a sense of how they thought about this gradual incremental process of reconstructing climate. He says, back in the 70s, it was a matter of testing just how far you could go in using a relatively limited area of tree rings to reconstruct remote climate. That was one of the building blocks of later work, because once you realized you could use an individual chronology to extend a climate reconstruction, I guess he's talking about tree, like a single tree. They were old, but then you would overlap the records of the trees, right? Then it meant you could look at the possibility of reconstructing hemispheric temperatures, say, from a hemispheric network of chronologies, which were not coherent and were not consistent. So instead of trees, think about thermometers, right? So each thermometer record is different, started at a different time in history. People didn't wake up in 1850 and say, let's measure global climate, right? They're also at they're not evenly distributed around the globe. They're at different altitudes, different heights off the ground. They're in different degrees of sun and shade. All of that was in a way like equivalent to the difference in situation that each tree had. And yet the dendrochronologists had figured out a way to kind of make all of these trees talk to each other. So you could say something about more than just one tree. And what we wanted to emphasize here, and this is kind of the contingency part, is like in the 70s, we weren't thinking, well, we'll do this and then we'll do the rest of the world. That was kind of, this was our little smoking gun, because we felt like this was kind of proof in a sense that they weren't thinking towards the global. I mean, as is often the case, they were playing, they were exploring, they were borrowing, right? Okay. So then this is also a lovely thing. See the sunglasses? That's Mick. And then the other person in the back of the photograph is a man called Phil Jones. The guy third from the left isn't so important, but Tom Wigley on the right was the director of the Climatic Research Unit who replaced Hubert Lamb. So that was, again, part of this change of generations. And he was a mathematician, not a geographer or a historian. So he was good with math and could just, he was just completely abstracted from climate. So there's this, again, this is like a lovely kind of moment, a micro moment in history where they have a lunch at the pub, which is what people do in England, and they finally relax a little bit. They have a drink, and they had a moment of inspiration. And the moment of inspiration was that they had this new climate data. That's the magnetic tape. So the magnetic tape from Jenny, Roy Jenny was a researcher at the National Center for Atmospheric Research, another imperiled institution in the US, and they had digitized climate data. So it was like, this is also a computer story, right? And he physically brought this tape to them and they said, we have this data. And then Phil, the guy in the back, who he had just done a PhD on rainfall in a river area. And he said, oh, I could use the gridding technique that I used to study the rainfall to grid the temperature data. So to solve this problem of how do you regularize, how do you homogenize irregularly spaced data? And not just irregularly spaced, but data that's in many ways not uniform, to justify creating a kind of larger data set. So he said, I adapted the program that afternoon when we came back from the pub lunch. Obviously, we hadn't had too much to drink. And then we put it onto the computing center on punch cards a few days later with the tape and produced numbers, and they looked reasonable, right? Again, there's no global here. It's just like, what can we do with this data? And they created database, actually, is what's important about it. It's flexible. It's something they can query. So the other thing to just say in 1979 is like the kind of the parallel history to all our kind of closer institutional stories is the rising concern over carbon dioxide and what was then called the carbon dioxide problem. There were increasing numbers of meetings happening because concern was growing, because there's the Keeling curve showing rising carbon dioxide measured on the top of the Mauna Loa volcano in Hawaii was a kind of very convincing, at least then, it was a very convincing indicator that carbon dioxide was rising in the atmosphere, which would likely soon have visible impacts. And so it starts to become, again, we saw with the Broker paper, are we on the brink of a warming? There's a kind of hunt on, can we detect warming? And so these guys at Crew are kind of entrepreneurial and they say, let's apply for some funding. And they get, interestingly, this UK little institute applied to the US Department of Energy because the US Department of Energy was funding research at that time into climate change. And they ended up receiving millions of dollars or pounds worth of funding from the DOE over 20 years. Working in collaboration with some of those people from the tree ring meeting. So this is also a kind of international collaborative effort. Okay, and more squiggly lines, but this is actually a really important paper. So what they produced, again, it's only Northern Hemisphere at this point. And I should say, I haven't said anything about the ocean because there's no ocean data at all yet in any of this. This is all land, even though there are historic ships data, and that will eventually come in. So once they had set up this method of gridding, which it became kind of easy to create different area indices. Because once you have your kind of nice, I guess it was like a spreadsheet or whatever with the data, and you could say, okay, now give me this latitude or give me that. And that's what this is showing, that they're exploring. I don't know if you can see on the sides, it's quite hard to read, but they're looking at like annual data from 0 to 85 degrees north. Then they're taking like just the mid latitudes, 25 to 55 degrees. They're looking at summer or winter. The details are not so important. What's important is that they're still doing this comparative contrasting thing that we saw from the earlier, but they're also starting to say maybe we can detect warming, and that's what that yellow highlight at the bottom. And so it indicates, and this is one of the first so-called detection papers that's published in 1981, which confirms that this cooling that had been observed in the Northern Hemisphere post 1940s, which is what, when you get these questions, there's papers published, global cooling, in 1970, because if you're looking at a certain window of the data, there was cooling since 1940. And of course, the natural variability was such that was the case. But they confirm that this cooling is no longer happening, and it seems to be warming, again, only Northern Hemisphere. Okay, this is just to capture the kind of culture shift that Crew underwent at this time. These are the covers of their in-house journal for 1980. And it's like halfway through the year, they discovered mathematics. And they start publishing these records of large-scale temperature. Still Northern Hemisphere, and sometimes like even a smaller bit of Northern Hemisphere. But the previous covers indicate the kind of, very different sensibility and methodology that they were using. Okay, so this is now my second unit. Very different. So if the Crew was like ground up, this is space vision top down. Okay, and I mean, so this says Modeler's World. James Hansen at NASA, GISS. I should have written out. GISS stands for Goddard Institute of Space Studies, which is based in New York. So Jim Hansen, who's very famous, I mean, at this time, he was a space scientist. He did his PhD on the atmosphere of Venus. So and he worked at NASA, right? His perspective was global, like from the start, right? And he was interested in producing a kind of fancy three-dimensional general circulation model of climate. And again, like almost like a side project, because those things were expensive to produce in time and in computing power. He and his colleagues who are in this photograph said, oh, let's just for fun see if we can do what's called a one-dimensional study of the climate to try and understand what the impact of carbon dioxide will be on the climate. So it's very simple. You only have like, instead of a globe, basically it's like a line that has the temperature at a latitude. Don't ask me for more details because I'm not as good on this. But so the point here is that he starts off wanting to understand, make a projection about likely warming caused by carbon dioxide. Very different from our guys at Crew, right? And he's oriented towards producing a computer model. So why does he need historic temperature? Well, to calibrate the model, right? So you have to make sure that your model can reproduce the temperatures that we know about to have any hope of confidence in its projections for the future. So he kind of just whipped up a historical temperature index to kind of populate his model. And because his model was sort of definitionally global, he was looking at carbon dioxide in a global climate model. He needed a global measure of temperature, and he called it global. I mean, others queried that, but the justification for calling it global, as he said, was that he comes up with this technique, and I'll just in the next slide try and explain a little bit. He says, with just a few stations in one of the grid boxes that covers the globe, you can actually justify the production of like, you can include that station basically. And then that means you can include stations from all latitudes. Again, it's still only land. This is an indication of two things. The sort of the thing with the plateau is the number of stations that are producing temperature data between, oh, it doesn't have the years on there. I think I cut off the years, but it's basically the surge happens in the 1960s after the International Geophysical Year in 1957, 58. There's like a big new burst of measurements. And the dark line shows you its percentages on the right. You can see that it gets to sort of 80% of the area of the planet is within the 1,200 kilometers, which he set as his, like, the size of the grid box. So he's basically saying, I'm telling you about 80% of the planet, and that's pretty good considering Antarctica and the Arctic. So there's like technical ways that they did this. Yeah, which was like kind of choosing the stuff that they would create the grid boxes and have a center point, and then take everything that was within 1,200 kilometers and then average that to that center. And statistically, one can then justify kind of differential weightings of those things. And so he uses his temperature record to come up with a very important prediction, I guess. So what's happening here is he is comparing his model. This is Hansen's finding. If you add the effects of carbon dioxide plus volcanoes plus changes in solar variation, so again, very reminiscent of the early work, right? Like there's still something kind of heuristic here, but also it's the case that these things do all contribute to warming or cooling. I mean, volcanoes cool, you know. The dark line is what the model produced for the time period. I think it's 1880 to 1980. And then the dotted line are is the temperature observations that he had generated. And the point here is that you get a pretty good fit between the model and the observations when you add them all in. So this is partly saying that all of these things matter, but it's more really saying, look how good my model is. Okay, and he wants the authority of he wants to shore up the authority of the climate model. So as I said, like the main question he's asking here is, what is the impact of increasing atmospheric carbon dioxide going to be on climate, and how does it compare to these other things? So the ramifications of the warming that his model projected, this isn't an image of the projections, but he included in the paper, were considerable, and even one might say catastrophic, right? They included things like the opening of the Northwest Passage through through Canada, sea level rise of 5 to 6 meters, the weakening and potential collapse of the West Antarctic ice sheet, new drought zones in North America and Central Asia. I mean, sadly, none of this is new to us, but this was the first time such projections had been made. And now Hansen, he took a move that he called his original sin, which was to contact a New York Times journalist who published a story on the front page that said, "Study finds warming trend that could raise sea level." It's actually not a sensationalist story, but what was really in the paper was sensationalist, that, Florida, 25% of Florida could be underwater, right? So this put global temperature literally on the front page, as well as climate change. There were critiques from fellow scientists, which we talk about, who said, hey, that's not global. You have no ocean, and we don't buy your gridding technique. But what we see is this sort of separation now between the public discourse, the beginnings of that separation between the public and the kind of back door. I mean, it's in the pages of Nature, but still. This is, again, just a placeholder card to say the ocean now starts to get added, okay? And this happens in a collaboration between the people at the Climatic Research Unit, working with people at the UK Met Office, and then NOAA is also generating data. You look like you know about this. Yeah, okay. And they have to solve something called the bucket problem to do this, which is about how if you they used to measure ocean water temperature using canvas buckets. They changed at some point to using metal buckets and also to taking water from kind of the intake area of a ship, which created an artifact of additional warming, which they very carefully took out. And that was a key part of generating a credible, fully comprehensive global estimate of global mean temperature. That's a quote from their paper. Okay, so this is like our iconic image, which it's not like the most beautiful picture, but I put it on the poster for this session because it captures, we titled our book When Temperature Became Global. And then we spent a lot of time arguing about when temperature became global. And we decided 1988 is a pretty good year for it. And that's the year that a very short note, I've reproduced it in full on the right there, appeared in in Science, sorry. I think is it Nature? Yeah. And it was signed by the people at Crew, the people at NASA, somebody who worked on the upper air, the UK Met Office people, and they don't have really that many footnotes saying our method is different from their method. They present this like very simple, clear visual that like, look, there's this thing called global surface air temperature. They give the kind of 5-year smooth mean, also showing the variability, and also the implication that this is something that can be updated annually. Okay. So it's a prominent display of scientific unity over the credibility and utility of the concept of global temperature. So in a way, that's the end of our story. And I knew I wasn't going to spend a long time on this, but this is just to say that it isn't, I think that image is can justifiably be taken as the emergence of global temperature as a metric, but not yet as a policy tool or goal. And so throughout the 1980s, climate policy is still evolving. And in a series of meetings, policymakers are discussing different potential goals for climate policy and tools, indicators for policy. And in 1985, they have only this very vague notion of greenhouse gas emissions, of having like an upper, a middle, or a lower limit. Then in 1987, at this important meeting held in Bellagio in Italy, they're getting closer towards thinking about global temperature as a management tool, which is the word that Jill Yeager, one of the participants, used for it. But it's rate of change of temperature per decade, not a threshold, and not, I was going to say anomaly. I haven't gone into that, but anyway. And then at another meeting in 1990, global temperature emerges as a kind of compromise indicator. But there's very clear understanding among the participants that there are many indicators, even in 1990, and I've listed, some of them there. And it's fascinating to see in this report, they actually say that, I think this was in one of our oral histories. Again, Jill Yeager says, global temperature was seen as this compromise because it wasn't looking at really long-term change that you would have if you think about sea level rise, but it also wasn't too rapid, which you might get from looking at the rise in greenhouse gas emissions. So it's kind of a just right in between for thinking about like how quickly policy actions could be taken. Okay, and so then this might be another year for when temperature became global, because you get the establishment of the Intergovernmental Panel on Climate Change, and they prominently feature global mean surface air temperature. Again, it's still land only, I think, in this. But it serves as a kind of core indicator for the IPCC for stating that climate change, that global warming is happening, and they refer to all of the different, they refer to like a handful of the groups. So that knowledge, I mean, they're sort of given individual credit, and yet it's aggregated. Okay, so this is just another way. This is my other slide saying a lot happened after 1990, and we haven't written about that. Partly because it's kind of like the contingency of our project. this book grew out of what was supposed to be an article about the Climatic Research Unit. And then we did the oral histories, and and so it really grew out of this kind of core comparison between these units, which seemed like such a neat way of capturing the contingency of global temperature, and yet its robustness, which we wanted to do. But it's only in the 1990s, well, even later, it's only post 2009 that you get a 2-degree target, and then net zero is even more recent than that. I think net zero is like 10 years old. So there's a whole other history to tell that we haven't. Okay, so my question for you is how do we deal with that? That our history stops in 1990, but it's very salient for today. And we don't really want to get drawn in. I mean, we haven't written the history. So, I mean, I'm even less confident than Mike is about that policy history, simply because we haven't done it. But I think that there are lessons that we can take from this. I mean, the main one is that there's a kind of ongoingness to global temperature. So it came into visibility, and it can also go out of visibility. And we may be at a moment where that's happening. I think it's also useful because it exposes how inaccurate climate scientists' histories are in ways that obscure a lot of, I think, really not only important, but potentially useful differences in the aims and methods that were used in the past. So one form of what it says usable contingencies of the global scale is that it draws our attention to regional and national and local scales, also alternatives to temperature. There's lots of different ways that you can measure climate. I think our history shows that the global was always part of a multi-scalar approach, right? Even those people who were generating it understood it as one of a family of tools. And also it helped create the authority of climate science by this, what do we say, a powerful disciplinary hybridity, which is a fancy way of saying it. It enabled the paleo, the instrumental records, and the future projections to be knitted together in a way that gave climate scientists authority. So I want to acknowledge that I think a lot is at stake in talking about global temperature and bringing this kind of scrutiny to it and drawing attention to its contingency. And I'm very committed to being able to have a conversation that is serious about the way in which scientific knowledge is made that doesn't undermine the usefulness of that knowledge. But it's not an easy, I don't know, the spaces where those conversations can be had are I don't know that they're shrinking, but they're not everywhere. It's not global, right? So I just wanted to end by mentioning Bill Gates put out a kind of letter around the most recent COP, where he said temperature is not the best way to measure our progress on climate. It's actually a very interesting and I think quite nuanced piece. And he's saying that global temperature doesn't tell us about the impacts of climate change. It doesn't tell us about health and well-being. He's not saying global temperature isn't real or climate change isn't real, but he's saying maybe we should think about things like a human development index. And there's just this is an example from Mary Robinson, the former president of Ireland, saying this is a dangerous intervention. You might be making a nuanced argument, but the people in Trump's White House will just seize this as yet another tool to dismantle climate policy. And then finally, I think there's a kind of good, aside from the policy side, there are good scientific reasons for thinking about alternate indicators. And this is from the most recent State of the Global Climate report from the World Meteorological Organization. And they're saying, actually, we want to introduce a new indicator. Global temperature isn't really so useful anymore once we've gone past 1.5 degrees. And also global temperature doesn't tell you anything about ocean warming because it's measuring surface temperature. And 91% of the warming is in the oceans. So they've come up with this Earth's energy imbalance indicator, which they say is a more holistic measure and which also is a better indicator of how fast warming is accelerating. That's what that bottom measure is. So I just put that up there to say that it's not just that there are like advantages from a scientific and policy perspective as well. So our final question is, can we use the past as a resource to create more capacious visions of the future and to try and, in line with critiques of GDP, to think about, are we measuring what really counts? Thank you for your attention.
Muchos.
Sorry for the.
Yeah.
If anyone wants to get distracted.
Ahora le damos la palabra a Luis.
Well, thank you so much, Sarah, and to Mike and Boris for sharing this really interesting work, and thanks to Carlos and to the other members of the Generante for inviting me to comment on it, and to Christina for organizing it all. And all of you for your presence and your participation. I'm going to try to be brief because I'm really looking forward to the discussion. And I know that looking around the room, there are people who are in different kinds of case studies that I think could bring to bear interesting details. So about what we've just seen. So I'll try to be very brief. And I also wanted to thank Sarah and Mike. They were kind enough to share the intro and the conclusions from the book to me as well. And so what I'm about to say is based on two sources, what we just heard, and also the chapters that they shared with me. And I approach this as an anthropologist who's currently working on an ethnographic history of environmental governance in late 20th century Mexico. And so it's really interesting the overlap in the time period, and to think about how the global in terms of environmental politics and environmental governance is being constructed during this time period. There are a couple of themes that I'd like to touch on. One is the question of scale. What does the global mean here, and how is the global forge constructed, mobilized in a way that permits the coordination of action, but can also be profoundly disabling in certain senses, particularly in terms of constructing local forms of action. And later on, I want to talk a little bit about this idea of the construction of the global, because I think it's not only a scientific effort to construct a model of the global. Thinking in particular about Jim Hanson's global circulation model that you mentioned, but also it's a political effort to construct the global, and it's a political effort that takes place in a moment of deep conflict between it was interesting to me to see throughout the presentation and also in the chapter that you shared with me, the contrast between the northern hemisphere and the southern hemisphere, because in the moment, the late 70s and the early 80s are a time of intense struggles over what the global is going to look like between North and South. And so I want to kind of bring that contrast into play. So first, reading the chapters that you sent and now listening to the talk, I was reminded of a moment in my own field work over 20 years ago here as an anthropologist in Mexico, where I was looking at environmental politics and also rural development and democracy in the state of Hidalgo. And I was working frantically with tenants in the ejidos, or the collectively held lands in the Tulancingo River Valley, which is leaving Mexico City and going toward the eastern Sierra Madre. And at that point, they're beginning to experience cycles of prolonged drought that are punctuated by these really strong flash floods, which have to do with hurricanes intensifying in the Gulf and other sorts of phenomena. So it's a moment of intense material loss because we're losing crops, but also the rivers are surging and being washed away. It has to do with water infrastructure flow. But it's also a moment sort of around the Korean crisis of 2002 and 2003, where there are some intense policy shifts that lead to rural people being thought of not no longer principally as agricultural producers, as protagonists in the story of national development, but as consumers, and sort of removing agricultural programs that are directed towards rural development and instituting targeted social programs that treat rural people out and sort of like support their ability to consume. And what's happening there, I think, in both a climatic sense, but also a political sense, is a loss of means of reading the present to anticipate the future. And I was thinking of back to this spring afternoon, as I'm walking with Doña Margarita Vargas, who's at that point 64 years old, through her milpa, through her fields, and she's explaining with great patience Las Cavernolas, which is a system, a traditional system for predicting the weather for each month of a coming year that's based on precipitation incidents in the first couple of weeks of January. And here, when you mentioned the idea of precipitation as an indicator that sort of left by the wayside, this is how she's thinking about predicting the future. And she says in this day in late May, the rain should have started by now. We're almost to the feast of San Isidro, and that's the point at which after the feast we usually plant. But lately the rains are coming later and later, and they're fragmented. They're not. She needs constant, gentle rain in order for the crops to grow. And instead of that, what she's getting are these sort of long dry spells punctured by black flood. So here in 2002, she is adamant to me. She calls it calentamiento global. This is what is causing the cavernuelas not to work, right? It's climate as a global hyper object with differential local impact. That's to say, this complex construction that we've just seen the history of how it's constructed through a series of compromises is read back through local observations that are focused primarily on precipitation. So this is what is causing the cavernuelas to become useless as a tool for reading the environment, and hence for taking care of the land, and hence for feeding one's family. And of course, global temperature and global surface temperature and the Las Cavernuelas are two very different ways of reading the climate quantitatively, right? There's a leap in scale here between the planetary and local that's incredibly impressive and very common, as you've shown us. And I think this speaks to a need for metrics as an agreed upon guide for reading the present and for anticipating futures. But it should also lead us to question what happens in that scale of reach, which I know is not the subject of your book, but it's one of the things that it caused me to begin to question for myself. And what other ways of observing and anticipating are being left aside when indicators become inferred, right? I think that's one of the really interesting things for me about this text in this presentation is not only the way in which this indicator is developed, but the way that it comes to have dominance in a particular moment. And as you're careful to tell us, global temperature as a scale is always multiple, right? And the comparisons are regional as well as temporal. But once it's enshrined as an inferred indicator, it collapses all over scale into the global, which displaces local and regional ways of understanding the world. And one of the things that we've seen in environmental governance paradigms here in Mexico is a struggle to align local measures with this global model and not the other way around. So this large scale determinism assumes that getting the global scale right will suffice, but it often overlooks biases at smaller scales, both for impacts are actually experienced. As I was reading this, I was also thinking about Hannah Knox's recent work on carbon footprinting. In the breach. In the scale of reach, we see the development of other forms of indicators that are requiring yet other forms of abstraction. And Hannah Knox is an anthropologist, and she her most recent work is on urban planning and the use of the carbon footprint as an indicator to think through how cities should respond to climate change. So we have first global temperature, and then we have this goal setting of we need to keep future temperature increases within that 1.5 or 2.0 degrees of change. We need to sort of restrict the anomaly in a specific way. And so the idea of the carbon footprint is a notion that allows us to assign individual or aggregate responsibilities for reducing that anomaly. And she has a really interesting concept here. She says that incorporating global temperature is useful in a way because it gives us an agreed upon guide. But on the other hand, using it for policy making, for example, in urban planning, is complicated and leads to what she calls a controlled equivocation. So the city of Manchester sets this 41% carbon reduction target for 2030. And she's doing an ethnography of all of the different ways that Manchester tries to think through what are the ways in which we can reach this target and whose responsibility. And so parts of the city come to be seen as either carbon producers or carbon sinks. And we're quantifying the carbon production of the carbon sinks, and we're thinking about the footprint in the city, but also in terms of individuals. And that leads us to specific strategies like changing all the way from changing light bulbs to changing housing construction to densify particular areas of the city. And it necessitates the construction of a whole new series of indicators that are established through what she calls controlled equivocation. We're going to pretend as if we know how much each house is emitting, for example, and that's going to give us a goal to reduce particular things. So the metric's not a direct discovery of climate science, but it's a negotiated settlement between the hyperobject of this global climate data and the bureaucratic need for legible, manageable units. And so it's interesting for me to think about what happens in this breach, both in terms of the reason that the global gets recycled into the local or reread through the local to try and help explain specific things, but also the ways in which it then spawns all these new indicators that are intended to sort of close that breach or make individual or aggregate at the level of the city actions scalable to reach the goal. The other thing that I found interesting for my own work, and I know for the work of several people who are here present, is the fluidity and the contingency that are present in the story of how global temperature becomes the dominant metric for climate change. And your work tells the story of scientific rivalry and contestation, but also I'm interested in the way that these negotiations are profoundly political. So global temperature is a scientific object with a distinct life story rather than a pre-existing physical entity that's just discovered in nature. It's constructed not as an absolute measure, but as an anomaly. The difference between current readings and a pre-industrial baseline from 1850 to 1900, which in the introduction you guys acknowledge is not that pre-industrial. It's a kind of thing, right? So this construction is a massive feat of aggregation at a number of different scales, where we're weaving together records from different thousands of stations, satellites, computer models, and then developing techniques like the gridding that you just explained that enable us to treat this data in a new way. And once it's established, global temperature is mobilized to function as a master historical narrative for our time. And it creates this sense of acceleration towards a dangerous, but also uncertain and unknowable threshold, like 1.5 or 2 degrees Celsius. Since its enshrinement by IPCC in 1990, you explain it's traveled reliably between the scientific and policy realms, and it acts as the bedrock for international treaties like the Paris Agreement. But before this, there's what you describe as a rivalry between competing global indices, the crew versus NASA, with different visions about what they're really measuring and modeling. And I really like the way in this presentation you underline the different stakes for the different groups. We have CRU trying to think about how we can use dendrochronography to aggregate different places, but also different time scales. And so it's sort of from the ground up. And then you have NASA thinking about what if we can make a global circulation model, right? What if we can see this from space? And as you mentioned, climate policy is still evolving in the 1980s, and there's yet at the time when these global indices are being created, there's no consensus yet on what the goals of climate policy should be, which is also a steeply political question, right? Because we're setting these goals also creates limits on economic development programs, right? And so it's a huge north-south debate. One of the things that's particularly interesting to me is the ways in which this sort of a convergence of diverse factors in this construction of the global in the 1980s makes the institutionalization of these indices possible. So these two working groups are offering, in the end, a unified narrative about the warming of the planet. And something that you mentioned in the interclusions that's not emphasized as much here, because we only have 40 minutes, is the emergence of Earth system sciences in the 1980s that gives a sort of global focus that places priority on modeling the planet as a unit, right? A lot of histories of environmental governance begin with that photo of Earthrise, right? Taken from outer space.
Which is so relevant since we just have the second Earthrise.
Exactly.
I think it's so amazing.
Exactly. And so the global is figuring in some interesting new ways at that point. And I think Earthrise is also important because it's a moment in which there's a greater investment in technologies that are permitting us, like computing technologies, for example, that are permitting us to create databases and work in those databases in new ways that allow us to project something called the global, which are not innocent technologies because they come out of military science. So I'll leave that there so to not spend more time on it. But what I really wanted to focus on is the global, the sort of policy environment that's sort of the 70s and 1980s, the Cold War, and also the gaining of strength in international or transnational institutions that sort of create this favorable zeitgeist that both demands and enables these kinds of metrics. So we're thinking about a physical globality at the same time as there's a political globality going on. And so in the first, we have the global temperature as a compromise indicator, right? I think that this question about how it becomes an emperor indicator has the politics behind it, right? If it's a policy action timeline, as we told us in the Bellagio conference, later it's adopted by the IPCC as a management tool and a policy metric. But I think there's something additional here about the forms of globalism that are being experimented with in the 1980s that I'm seeing in my own recent archival work that has to do with the construction of Mexican environmental policy in conversation with what's happening in Europe and Canada and also in the United States. So in the 1970s and 80s, there are coalitions of global South countries that are pressing for this, what they're calling a new economic paradigm, to reconfigure the balance of political and economic power. But by the 1980s, under the Reagan era, and certainly under Margaret Thatcher, that these two actors start to view these very global entities like the UN or the IPCC. The IPCC comes about later, but the UN environmental platforms in particular, as giving too much leverage to the global South, and the environmental theme in particular as seen as a theme, where the global South is having too much protagonism. They're being too much power to sort of set global agendas in a way. And it's really interesting when I find what I found last year in the National Archives of the US, and particularly looking at the EPA and the Bill Bubble Shelf. There is a push for EPA, the Environmental Protection Agency, they have a whole international branch, and it's running all of these collective conferences with Japan and Russia, and trying to create collective projects, or at least coordinate different projects that are measuring global temperature and doing other things like looking at agricultural productivity in particular. And so they're both using, there's an idea that you can tell a good policy story with environmental cooperation, and so therefore we should invest in it more. One of Rockwell Texas underlings is the head of the International Environmental Cooperation Office, calls it a bright spot on the international agenda. And so there's this sort of soft power narrative, but it's also backed by the idea that's very explicit in correspondence between all of these different bureaucrats in the EPA, that if we can get out ahead of the negotiations, then the US and Europe can establish these standards. And that means we'll be able to set standards and metrics that we are more likely to want to comply with. And also we can sell this technology to the rest of the world. So there's a soft power element there that's very, very interesting to me. But also at the same time, in the late sort of from mid-1970s on, Mexico was trying to create national level environmental policies, environmental policies not connected with water infrastructure, or not subsumed by water infrastructure or human sanitation or things like that. And in the development of environmental standards, we're looking to Europe and to the US and to Canada, but it's very clear in a lot of these archives as well that the need to adapt to what all of these functionaries are calling Mexican reality, in conversation with other scientists from the global South, trying to think through how to create standards that are both in conversation with what's happening at this thing that we're constructing and calling global, but which is actually very heavily Anglophone and very heavily tilted to the US, the EU, and Canada. But they're using indicators and also standardized procedures. And my current work is on environmental impact assessment. They're using these things as a check on vertical power, which is really, really interesting, both domestically, as a guide to decision making about budgets, about development agendas, about development projects like dams, for example, or electrical power plants, but also internationally. And right now I'm looking at the La Paz Agreement, which is the negotiation of the La Paz Agreement, which is the first border environmental agreement between the US and Mexico. In the negotiation really begins in the late 1970s, but it's concluded in 1983. So it's exactly this period that you're talking about when the global is being constructed in terms of the environmental policy. And they're looking for indicators and standard procedures that can be adopted strategically in order to attenuate vertical power moves internationally as well. So if we move the frame a bit wider than global temperature itself, I think we see that there are some other factors that are at stake in globalism at the moment, and the adoption of what we were calling emperor indicators, right? I love that term. I understand you guys borrowed it from the studies about GDP, but I think it's a fantastic way to think about it, because as you point out, there are so many other possible indicators that are not exactly discarded, but this becomes a compromise indicator because of what it allows us to do bureaucratically, politically, and diplomatically. So these indicators fill a bureaucratic need because they permit coordination and evaluation of policies and the results, but also a diplomatic one in a context where global North and South are arguing fiercely about how to assign historical and future responsibilities for particular aspects of the North itself.
So now you have an opportunity to.
I will respond, but briefly, because I want to hear other
Okay, we have time.
other comments.
That was 15 minutes later, we have half an hour.
Okay, fine, but thank you so much. I mean, I guess the first thing to say is like it's such a good feeling to feel finally in conversation and having worked alone. And I hope it's clear that, you know, our focus is on what we might call science. There's a lot of policy and politics in the book as well. But the intention of the book is precisely to create more awareness of what you call, I think, the scalar breach, or these lovely kind of the example you gave of the woman saying the global temperature is messing up this, you know, to, I mean, in a very basic way, show really how problematic global temperature is as a way of measuring impact and how much it obscures. That's a kind of critique, I guess. And I'm always more comfortable making critiques sotto voce, right? Like letting people figure that out themselves. To me, that's like my role as a historian, is like I'm telling the story, and you guys, maybe you'll have a light bulb moment and say, oh, there's this, it doesn't have to be this way. And why is it this way? And we focused on the kind of contingencies within the process of the kind of, one of our readers called it inside baseball. So like the technical histories of these indicators of global temperature. But one could also tell a history of the policy contingency of it. And we have tried to do that. I mean, we've alternated our chapters to do that to a certain extent. So basically it's just to say, like, I'm glad to start that conversation. And that's sort of an interesting thing about studying the history of science, especially if you're doing it in kind of Europe and America. So you're telling the history of a certain form of power. That's not the same thing as justifying that power, right? I still think we need to tell those histories. And I think it's quite interesting that this is the first serious history of this incredibly consequential thing, which just shows you that how much authority it has, that it can come to seem like an object without a history, right? The other thing that I'm glad that you mentioned was the Cold War, which is obviously important. And it gives me a chance. So I just finished another book too. I was doing this crazy thing of writing 2 books at the same time, which was very risky, but it seems to have worked. And the other book is about the history of the limits to growth, which was published in 1972 and was the first time that computer models were used to produce planetary trajectories of the future, not using global temperature, but exploring the relationship between population and pollution, right? And part of what interested me about that is that they use this tool called systems dynamics to do that, which is about feedback loops and delays, positive and negative feedback. And the point was that it's these systems are complex, and if we want to understand them, we need to take into account these counterintuitive effects, and we need a special tool to do that. And I mention that because a key institution that I didn't talk about in this talk, but could have, is called IIASA, the International Institute for Applied Systems Analysis, which was also founded in 1972. And in the book, we talk about, briefly, a really interesting and important paper that was published by William Nordhaus, who's a Yale economist who was given the Nobel Prize for climate change, interestingly, because he essentially did pioneer the field of climate economics. But what he did at IIASA in the mid-70s was for the first time create a model that linked GDP and global temperature. And it's this short little paper, and he uses the tools of economics and pricing mechanisms and a very rough estimate of, like, it's very back of the envelope, 2 degrees by chance, in a sense. But what he produces is a justification for the management of climate change, that we can use market tools to manage climate change. GDP can be the kind of knob of not GDP, global temperature can be the knob that we use to set the global economy and allow ourselves a certain amount of carbon emissions. And what this paper produced was the sense that actually we can keep emitting for a little while because we know how to deal with this.
How like the economy.
Yeah. The technologies that we need will be soon developed. Sub-technologies. But that and IIASA has been the place where a lot of the important so-called integrated assessment models that are used by the IPCC to project change have been created by people there. And the point that I meant to make is that IIASA was originally called East-West Institute. It was specifically designed to foster contacts across the Iron Curtain. And systems thinking, which evolved to be systems thinking for climate, was chosen because it was seen as a tool that could create collaboration across ideologies, because it was sort of seen as apolitical but universal. And so there's a kind of interesting story to tell about global temperature and climate change, which sees it as basically a tool for maintaining the status quo, that the Soviet Union and the West kind of created some mutual stability there. And while they were doing that, they were not engaging with the global South concerns about the new, economic international order and all of those things. And the world that we live in today, well, not the world, the evolution of the IPCC in some ways has enshrined that method of we've got this, we can manage, the whole notion that you can manage global climate isn't, I think, a Cold War idea. So that's just to say that governance, totally. And, there's different technologies for thinking about the future. General circulation models are one, economic models are another, these integrated models are others. And you mentioned the woman, what are they called, the cabanuelas? Yeah, so that's another technology for thinking about the future. And so I guess as scholars, it's interesting for us to compare why some have authority in some places and how that changes. So anyway, I'll leave it there.
Want to say anything? No?
I want everyone else.
Yo, abrimos la mesa a preguntas, comentarios cortos. Tenemos un poquito de tiempo, no mucho. También a quienes están, me han reportado que hay más de 20 personas conectadas, lo cual nos da mucho gusto. También pueden escribir sus preguntas o comentarios y los veremos en voz alta. Por favor.
Thank you, Sarah, and thank you, Annalise. It was super interesting to hear about this book, or the free of the book. Looking forward to reading it. I have 3 questions. I hope to read it. The first one is about this, what you mentioned about this Eurocentric way of thinking about the temperature and this global market of climate change. And I thought about what, well, first of all, my name is Teresa. I studied the climate scientists in Mexico who built the first climate scenario, the national climate scenario. And now I'm working in integrated assessment models,
Right.
how climate scientists in Mexico are using YASA's integrated models and other integrated models to produce policy intervention. Well, just I'm saying this because from that side, from that view, I'm asking this. So I did interviews with climate scientists in Mexico, and I was thinking about how climate scientists and modelers will think about this notion of the temperature as a neurocentric metric, which I understand it has a whole basis for arguing this. But maybe regarding the precipitation, because it is the uncertainties around the precipitation I'm thinking about that makes almost impossible to build a media of a global mean precipitation. So
Right.
in this
Yeah,
sense,
but global go together.
exactly,
Yeah.
exactly. In a way, like
They do.
beyond, well, thinking about not only like there are perhaps scientific, well, earth natural perspectives that will say why precipitation is so difficult to put it in a global,
Yeah.
more than the temperature metric. But I understand that there are problems around the temperature, like building this thing, but perhaps if you can, there's no more about this. And then the second question has to do with what Annalise was reflecting. This idea of how both were reflecting, like this idea of how the climate global temperature is a fragile product in a way, like it's not this convention that has no questions to be made, and how that global measure is actually in like fostering all these policy goals that Annalise was mentioning, and how this global metric became a policy target, and in that sense, how these policy targets are actually so fragile as well. Like basically that global fragility, or even, I don't know how to say it, like it's super interesting to discuss it. And then that brings me to my last point, which is we in Mexico, as far as I know from scientists and the revision I did, we only have a global country mean temperature of how our temperature was rising until 2023, recently, very recently. And the measures show that Mexico was, until looking to the 19th century, the beginning of 19th century until 1930, that period of reference up to 2022, doing that analysis, the global mean temperature was 1.23 Celsius degrees, and the Mexico's rising temperature was 1.69 Celsius degrees. It was above hotter.
Yeah.
Exactly, it was above the global mean temperature. So in that sense, I'm wondering to what point having our local, maybe empirical indicators allow us to locate the discussion, to have a discussion, because it will be different in each geography, but in our country, the history I follow climate science, doing climate science, have been deeply precarized. Deeply precarized? Or how do you say it? Exactly.
Okay.
Since 1994, that we had the first scenarios for the country, up to now, we can argue that. But the point is, when these indicators from a national view, which obviously obscures the specificities of the heterogeneity of the country and so on, but it builds a space for discussing this in a more serious way, in a way that we can start doing the impact discussion, like, and the risk and the vulnerability, like, to place in the policy spectrum this discussion. So in that way, I don't know, perhaps indicators will play different roles in different moments and geography. Yeah, so thank you.
Thank you. Those are great. I've taken my notes.
Okay. So brief.
Yeah, I mean, I think, I'm not anti-indicator. I think the point is to create the possibility of multiple indicators and comparing indicators and a sense of a sensitivity to the power that is embedded in the indicator and for whose interests are being met by it. And so, yeah, it's interesting to hear you say that like Mexico kind of could maybe use a national indicator of climate. Is that what you're saying? Like it's useful
to have finally like the temperature we live like when we talk about climate change, all references were about IPCC, but we didn't have that number for us.
right.
Not that the number erases all the problems, but it makes to have a national reference.
Yeah. So in a way, you're making both points. You're saying that like the global is inevitably obscuring the things that really matter on the scale at which, let's face it, most policy is likely to happen. I mean, global climate policy has been largely non-existent in terms of action, right? But that there's also the risk of the national indicator obscuring other things, right? So it's indicators all the way down, or it's scale, it's that's the point about like having a multi-scalar sensitivity. I mean, I don't want to be an evangelist, like it's doing that, right? And that's why we've struggled with the lessons actually. And that's, you know, because I think that would be to miss the point, to say like instead of X, Y. And you're very right to say that like there's very good reasons actually why temperature is a very malleable metric with which to create a meaningful at a global scale in a way that precipitation where you have on or off or like sudden changes is I think in a way impossible to deal with that way. So the sense that global temperature is fragile and that therefore our goals are fragile, is that a problem? Or is that like an opportunity to think about designing policies in different ways that are maybe more, you know, iterative and reflexive and responsive, right? That is there something unhelpful about the notion of a fixed goal, especially when you start to hear the rushing sound of passing the goal. I think that's why this moment now, for a lot of reasons, 1.5 degrees in global temperature starts to look not so useful anymore. I think both on the left and the right is what I was trying to say. So I guess then the answer has more to do with how we think of the policy process and what we think of the relationship is between science and the policy process. And, you know, for how long have people been trying to get away from a linear model of science and policy? Like at least 50 years. You know, it's an ongoing practice. So I'll stop there. I don't know if you want to say something.
It's a politician limitation.
Yeah.
And thank you very much. Vamos en ese sentido. Luego tú, vamos a juntar los para que. Entonces, perdón, no sé sus nombres, pero ustedes pueden decirlos.
Gracias. Thank you, Sarah and Annalise and Lorena. I come from Sage.
Sorry, Adrian.
Well, I come from Sage and I'm doing a postdoc precisely on how climate change, well, the environmental crisis more broadly, because it also involves the death of different species.
Absolutely, yes.
So how the environmental crisis is representing a historical and epistemological break or rupture in our understanding of the planet. So and I'm at the very start of the project, right? But I'm very, very interested in this point of production of knowledge. And well, I don't know if we could call it levels or this spectrum. I mean, I'm actually not, I haven't quite solved this point of knowledge and discourse, right? And narrative. They're not quite the same thing, but they're quite apart. Yeah, but the point is precisely, I would like to hear your thoughts on this precise breach between what's going on in academia. And of course, within academia, there are dissidents, right? But for instance, academia, the media, then political discourse per se, for instance, what happens at COP20, whatever, which is obviously the most, appalling thing, discouraging. And then actually lay people's understanding of the planet and, just the public or collective imaginary we have, and how, for instance, global temperature has become this kind of of notion that, you know, it's pinned there for all of us, right? So I would just like to hear your thoughts on this breach, and how at some point there is this current where there is some kind of consonance, but also those dissonances, how they're affecting our understanding of the world. And here I just want to say quickly, I'm thinking of James Moore's work. I've been reading a lot on him, Capital in the Web of Life, and this idea of the disciplines as shaping our understanding of a fragmented world. And then Dipesh Chakrabarty's book, Climate of History in a Planetary Age, he's also bringing to light this kind of shift where we suddenly started talking about the globe and the planet, whereas before we weren't. So yeah, I would just like to hear your ideas on that. And then finally, I just want to acknowledge that there's this article, this whole theory propounded by Johan Rockström and his team of collaborators on planetary boundaries.
Sure.
So, what do you think about whether these could also be incorporated, perhaps, and the relevance of incorporating them also to environmental governance and policy making, when, as you say, temperature stops being just as useful? Thank you both again. Yes, this was amazing. So much more to think about.
Yes.
Hi, my name is Omar. It's very nice and both the link between both approaches. I mean, because it's so different, but at the same time, you arrive to some similar problems. So I like a lot the idea of the openness of these scientific measures. I mean, that is not already something necessary. And also the relationship between the global and the local, with all the cultural political implications, I think is quite interesting. I like I forget my first question, but well, the second one is about the local and the global relationship. What is the important thing? I mean, because when we focus on these global indicators, we are already involved with this global approach, no? But I think that it's something similar with the Anthropocene, no? We are trying to look for these global geological indicators, but as you mentioned, the impact were local, no? And also the political action. So maybe we could recover other kind of indicator approaches that is more important for local places, such as the rain, which is so useful in India, but also here. And I like to mention only two works. I'm talking about Anthropocene, the work of Eleanor Melville about the Hidalgo. That is a lot Anthropocene. The Mesquite Valley. Okay. So I think it's quite important this dislocated local approach, no? And that early and very local impacts. So also Rolando Garcia, I don't know if you know the work, he has this work that is about the famine in the African Sub-Saharan in the 70s, that is called Nature Please Not Guilty.
Nature Please Not Guilty. Is this the Sahel crisis? In the 1970s?
1970s, yeah. So I'm talking about this twist between the 70s and the 80s, because I think that it's a very interesting approach, more holistic, that then later will be not developed and will not continue, no? So he comes here and continues his studies. But the line of his research that is more focused in the interaction between social and nature climate is not developed anymore, at least in that time, no? So I think that's interesting, this institutional change, no? So.
Gracias, Omar. So,
Do you want to start with, you were nodding a lot, but okay, no, because I responded already.
Also, fan of Eleanor Melville. I think one of the interesting, so it's the first environmental history written in Mexico, and I believe is it 1980, something like that.
No, pretty.
And lots of environmental historians will argue with it now. But basically what, it's called a plague of sheep. And it's about what, the way that colonialism changes environments in Mexico and turned an area that was very carefully managed by the old community, the Nainu people, into a desert. And it's interesting to me because she's using a lot of archaeological evidence, and so thinking about the ways in which dendrochronology as an archaeological technique is being pressed into service in climate science at that moment is interesting. And it gives me sort of another element to think through about what she's actually doing in that moment. But I think it's also interesting because she's also speculating using colonial records, using archaeology to try to sort of project backward and think about the ways in which environmental management techniques are collapsed in the colonial period. It's published at a moment when exactly in this context of when we're trying to think about how we can link present environmental changes and climatic fluctuations with the past. But it also has an element that I think is really fascinating, which is to say the ancestors of the Nainu managed this environment, which is in sort of an ecotone between the mountain and the desert, where the management of rivers is very, very important. And they were agriculturalists, and they're so producing and managing the ecotone in order to increase rainfall and to increase moisture is important in terms of being able to support a larger and more complex population. But it's also important because in the desert to the north of the Chichimecas, and when the desert expands, they expand as well. And so there's some political stakes for them in this moment. So I think for me, it's a really landmark study that I still use in my environmental history class, so it's all the time. But it's doing that thing that we've talked about of trying to knit the past, the present, and future again, because she's pretty explicit about saying if this ecotone could be managed before, it can be managed again, right? And it can be managed in ways that make sense in this place and with techniques that come from this place, not necessarily from elsewhere. And so I think that for me is one of the great values still of that piece of work.
And that's interesting, that contrast with this notion of rupture that you raised, which I am allergic to, I have to say. Or I put it differently, I want to historicize it.
Yeah.
So, and I think Chakrabarti wants to assert it. And I think there's a politics to that assertion. And, historians, we want to see both, this continuity and the discontinuity. But the last book that I wrote was a history of global climate, written to demonstrate that it's 100, that you can see in the 19th century versions of the globe, which aren't identical to what we have today. And I kind of ended with the Brotherton diagram. I don't know if anyone knows, that's the classic diagram of Earth system science, which is like the plumbing map of the Earth that brings together all the scientific disciplines of studying the Earth to say we can have like a total science of the Earth. And then famously there's this little box that says human activities.
The original black box.
Right. And so, so I guess I would say my response to that is like to be a little critical, and not in the negative sense, but in like what is achieved by asserting a rupture, and what, like, whose interests does it serve, and what forms of knowledge then are you left with? And what I find it strange that there's this desire, like this in this Anthropocene orientation, to collapse kind of humanities kinds of knowledge into science kinds of knowledge. I feel like my instinct is exactly. And so I always want to disaggregate, and I actually think that's one of the wonderful things about history of science that I can fly the flag for, is that it gives us tools for understanding why different forms of knowledge have different forms of authority at different times, and I tried to like draw that out. And the politics of multidisciplinarity, I mean, it doesn't always function that way. Sometimes it's about repulsion as well. I don't know if I can say anything super intelligent about your question about like the relationship between fields of discourse. I mean, except to say that maybe it's like maybe a systems approach is useful, that, and it's about maybe one way of understanding these things is like the intensification of the relationship and feedback between discourse that is still somehow scientific, discourse that happens in the public and the policy, and that there's this kind of desire that we seem unable to let go of to keep these things separate. We want to have we want to maintain distinctions, but maybe if we keep trying to do that, we're missing what the real phenomena is, which is like the feedback between them. That's a very abstract thing to say. And again, I will just like go back to me, like the historian in me, which is to say, you know, diagnose it. When do those particular spheres of knowledge and the discourse that goes with them emerge? And when do they come into contact with each other? And that, I guess, maybe gets to your question about like moments of openness towards different ways of thinking. And it, you know, I think that is what I hoped this book would reveal, is that there were these moments, and that it wasn't missionary. It wasn't like they said, "Oh, we resist the global." There was no global to resist. But in their exploratory aspects, I think there's something we can learn from that. And the politics of the moment that we're living in have stolen from us some of that ability to explore together in all kinds of discourse, right? Including in science. And I think, you know, it is problematic now to talk about like a dogma of climate science when climate science is so much under threat. But those things are related. You know, the climate scientists had to circle their wagons and they had to present an appearance of consensus. And I think actually that gets back a little bit to global temperature, because there was this need to kind of shore up the claims about global warming, and global temperature at the global scale was a really powerful tool to do that. So I'm not saying this isn't about like a judgment and right or wrong, but we can see it in that context. But now, 30 years later, there's sort of repercussions from that, which means there's a kind of rigidity, I think, or we've lost the ability to say certain things in public about the relative benefits of certain kinds of knowledge, right? And so if you're seen to question global temperature, I mean, I've already had that conversation at a party where someone said, I think it's really dangerous that you're writing this book at this time of the climate crisis. Yeah, and I know, okay, well, that's a good conversation to have had, and I need to make sure that I sharpen the focus to deal with that. Yeah.
Well, can use for different purposes.
Right, but not to be naive, that everyone will be sort of open to the nuance, right?
So we have time for one question, or probably two. Then I'll read two very short questions that arrived through the. So, please.
Well, my name is Carlos. I work here in the Institute, doing PhD on philosophy of measurement.
Okay.
So
Yeah.
I would like to join my colleagues in thanking you both for your interventions. They're very insightful. I have more of a curiosity question for you.
Okay.
Because I understand since the beginning of your talk that you said you start with the point that we have the material mediums to collect the data. But I was wondering if you find that there is like a lot of work in the history of the instruments that are used, or would you say that there is like a field of exploration there to be done?
Do you mean in terms of the historians' work or the philosophers?
No, sorry.
Or both?
Yeah.
Should I answer that right away?
Yes.
I can just quickly say yes. I think there's a big difference between crew and NASA in that sense. Like the crew people were like very tuned to all the problems with the data. They lived in the problems and they painstakingly figured out ways to homogenize it and calibrate it so that it would be robust. And Hansen was like this big arm weighty thing. He kind of came up with this tool that enabled him to sort of throw a lot together. And actually the global average temperature measurement is very well suited to that because it's averaged over a period. So you smooth things out. Yeah. So yes, I think one could do a lot of interesting sociology, history, and philosophy of that. And of course, the ClimateGate scandal of 2009, I don't know if that made it to Mexico, but the emails of the people at Peru were hacked, they think by Russians, to try and undermine climate negotiations at the time. And what the hackers showed was the scientists saying, oh, you have to do the trick to make the data work. They were talking about like statistical manipulations that are sort of part of the work that they do. But when it was exposed in the way that it was, it made it look untrustworthy, not credible. So absolutely.
When was that?
Sorry, when? 2009.
Yep.
Climate date, yeah.
So I think we will stop there. I have questions, but I will ask them over lunch because there will be another conference by each one of you. My questions are always so vague. But there are two questions that are even vaguer, more general. That you don't need to answer, but I do want to read them out loud. María Eugenia González asks, in Spanish,
Okay.
a lo largo de esta evolución climática, ¿es viable que se pueda revertir esta tendencia al incremento de temperatura? ¿Y qué escenario consideran las presentadoras más favorables para eso?
Does that mean can we undo global warming or the
Yes.
global metric? Global warming.
Warming, temperatura.
Well, that's a totally different.
Y the other question is solved by a collective called Naturaleza para Todos. Gracias por este recorrido tan revelador. En su opinión, ¿qué falta para que la población pueda actuar cotidianamente para enfriar el planeta? So very similar worrying questions that we...
Is this chance for joining again?
Yes.
Very quick question, like, I was wondering about the metric, like, if there was a close metric competing with the temperature or not in this reconstruction of having this empire metric, but who was just for curiosity, like, who was the other one kind of close to, not the one, I know
Yeah.
there are groups of people that the runner-up.
I think the point was actually that it was the multiple.
Okay.
So there wasn't like another singular. I mean, maybe sea level. But I don't think so. I mean, I haven't studied that. But from my sense from what the materials I've looked at is that it was more like a kind of group thing out of which one emerged rather than a kind of campaign.
Bueno, muchas gracias. Por cierto, si quieren seguir la conversación, algunos de nosotros vamos a ir a comer algún lugar cercano. Y entonces está...
So I shouldn't try and answer the questions.
No.
I feel like they're important.
Oh, well,
I don't know a good answer, but I think it's right that a conversation like this should raise the question of what can we do.
okay.
So I would like to acknowledge that thank you to those people online who asked those questions. And I suppose part of the idea of the history is to open up space for a conversation about what we should do that's different than the conversation that we normally have, and perhaps having different targets and different scales of action is important. And, the tension between individual action and sort of global policy is problematic. And so we need to be creative about it. But I think we need to find ways to reconcile them, to not make them seem like they're opposed, but that they're part of the same. But
You want to say something?
Preguntaron en español,
Sí.
pues contesto en español, pero lo que a mí se me ocurre, gracias por hacer esas preguntas, estoy de acuerdo con Sara, que es una importancia cuando empezamos a entender esta historia, preguntarnos, pues, ¿qué se puede hacer al respecto? ¿No? Esto es muy importante. Y si algo entendí yo, de esta presentación tenía que ver con el hecho de que en algún momento la temperatura llega a ser como un indicador dominante, pero siempre hubo y siempre habrá otros indicadores. Entonces, para mí la pregunta no es, claro, es muy importante poder controlar el aumento en la temperatura, pero por otro lado pensar en todos los demás componentes de los cambios que estamos viendo a nivel local y a nivel planetario, donde sí podemos contribuir. Vivimos, por ejemplo, en una ciudad que se está calentando porque estamos pavimentando muchas cosas, pero también porque enterramos nuestros ríos, pero también porque... Entonces hay un montón de actividades que podemos hacer como ciudad y como colonia. Yo creo que lo más importante que podemos hacer es empezar a organizarnos con nuestros vecinos y ver qué es factible hacer en cada lugar con la tecnología y las ideas que tenemos en este momento, pero ya empezar a hacerlo.
Muchísimas gracias. Bueno, antes de cerrar, quisiera agradecer a los técnicos que nos han apoyado. Cristina, y bueno, ahora sí, juntos vamos a darles un aplauso. Estén atentos para el siguiente itinerante que se va a anunciar. Y muchas gracias por asistir. Very much. That was great.